Okay, so I'm just going to make a new project whenever NetBeans loads. But the point that we would want to use this slash single quote and slash double quote is because what if we wanted to print this? And I'll probably type this actually into NetBeans in a minute. What if I said S is equal to C colon backslash new backslash text dot 1, 2, 3. And I printed it out. Here's what it would do. It would print out the C, it would print out the colon, then it would hit this backslash in, which is like hitting the return key. And then it would type in EW, and then it would see the backslash T and convert that to a tab character. So jump over there, ext.123. That's probably not what I wanted it to print. So what I can do is if I put slash slash there, the first slash says, uh-oh, we have an escape character coming up. The second one says, no, I was just kidding. Go ahead and treat it like it was just one slash. Same thing here. We put that there. So, okay, an escape sequence is coming up? Nope, not. And so then when it printed it out, it would print out C colon backslash new backslash text dot 1, 2, 3 like that. Yes, sir.
And so that just bypasses it entirely whenever you do that?
I'm sorry, pardon me?
So that just bypasses it like the tabbing, things like that?
Exactly, exactly.
Because
It fills it in so that it doesn't do this. Instead, it just prints that, and that gets turned into a single slash.
the other day I was trying to, like I wrote a program in Visual Studio that was trying to, it was going to print out like a boilerplate for like HTML stuff.
Yeah.
And it kept like tabbing it over when trying to fix it. So.
Right, right. So the various languages have different ways of handling that. C++, C Sharp, and the Visual Studio, they have some special way of saying, oh, by the way, this string is an exact string. Don't do anything with the escape sequences. And I don't remember what that is, and I wish I did because it's real useful. But, you know, then even if you had some backslash T's in it, it would print those out rather than hitting the tab key. I'll try to remember what that was, how you do that. Okay, so here's another example. What if you did this? S is equal to, my name is Slim. And then you print S out. Well, that's not going to work. Because what it's going to do is it's going to parse it like this. My name is, okay, that's the end of my string. And then it's going to see this here, and it doesn't know what Slim is. It doesn't know why we followed our string with some text, right? It's trying to treat this as though it's one string, treat this as though it's another string, and treating this as though it's acceptable Java code, which of course it is not. So what you would really need to do is backslash there and backslash there. And so backslash double quote gets turned into just a quote when it prints it out. So in that case, it would print out. The other would have been a syntax error. We could not have even run it. My name is Slim. That's what that would print. Then there's backslash single quote. Now, why would you need that? Most of the time you don't, right? If you put cat says single quote, meow, end single quote, end double quote, semicolon, and then you print S, that would print out perfectly. Cat says meow, like that. Why? Because there's no confusion. Double quote, great. Double quote marks the beginning of a string, double quote marks the end of the string, and whatever the stuff is inside here, that's great. So it would print it out. But what if you had a single character you wanted to print out? Char C is equal to, and you wanted to make it apostrophe. Well, characters are defined with single quotes rather than double. So that's what that would look like. Well, that looks pretty weird. And yeah, it would be a syntax error. So if you wanted to assign an apostrophe character to a specific character, again, you have to use the escape sequence. So let's write out somebody. Slash T is a tab, slash N is a new line, slash double quote is a double, slash single is a single, slash slash is a that. That's probably all that they list on the PowerPoint. Yep. Okay. So if I have that being loaded now, Visual Studio, go away. New project, if you feel like playing along. Java application. I think today is Lecture G. I'm going to divert my attention from talking about what's in the PowerPoint to what this package keyword means. This is like a library. You can put several files inside the same package. And then you can create another package in your project and create and add several more files there. It's a way of divvying your project up into subsections, subdirectories. I wish it'd stop spinning this little wheel. Well, anyways, so if I go out and find my NetBeans folder, wherever I'm storing this stuff, documents, NetBeans projects, Lecture G, source. You notice I have a source directory, but underneath it, I have a package called Lecture G. Now that was created by this keyword. Actually typing it into NetBeans caused it to create that. Now NetBeans did it for us, so we didn't see that happening, but it did. We could change the name of the package if my cursor would ever stop. Well, I guess I'm going to do so anyways. What if I hate the name Lecture G as a package and I just want to call it my code for some reason? Well, now that I've changed it, NetBeans notices that it's an error. Why is that? Because it is still sitting there inside the Lecture G directory. If I go in there and I look, then my Lecture G.java is still there. It needs to be removed from there and put into my code directory. I could do that, but I can also let NetBeans fix it for me. I can come over here and do either move class to correct folder, in which case it'll make a new folder, or change the package declaration. If I do that, then boom, it's back the way it was. Maybe that's what I wanted, but no, I actually wanted to move it into the directory called my code. So I click that and do move class to correct folder, and then when I save it, come back to my folder structure, I see that there's a new directory called my code. Now, I would be pleased as punch if y'all just deleted that line entirely as a matter of habit every single time you create a new class. The reason why that is when I'm grading your homework, I don't load each project into NetBeans. I don't usually load your entire project. I just copy your .java file, paste it into my editor, and run it. And every time I do that, I have to remove the package statement to get it to work. It'd save me 2 seconds if y'all did that. Now that I've done that, though... Pardon me?
You were just about
Exactly, right. Well, the problem is that now it's in the incorrect package again. There's no package at all, so where the code needs to be is right here in the source directory, not in some subdirectory. And again, I can fix that. NetBeans offers 2 choices. One is to move the class to the correct folder, which is what I want to do, or the other is change the package declaration, which if I did that, it'd just undo my comment. I mean, it would undo what I just did. So move class to correct folder. Now, when I look, my .java file is in my source folder. And I now have these 2 empty folders that I could go and delete. NetBeans isn't that smart. It doesn't delete your empty packages. But I could delete them if I so wanted to. So I will try, when I'm typing in code up here, just to get you in a habit of it, delete the package unless you have reason to cluster the packages together. Now when you create a new class, and I'll answer your question in just a second, it does this, create main class. You see that right there? That is the package. You could delete the package even as you were creating the project. I could do that, and then it would not add a package line at all. So maybe I'll remember to do one, maybe I'll remember to do the other. I don't care, because I can delete the line package from your homework pretty easily. Yes, sir.
Can we also get rid of all the comments about the package?
Let's look. You can. It would certainly be prettier if you deleted that.
First thing
I
I
agree.
just got on my comments, so
Yeah. Okay, so what were you going to ask?
you probably just answered it, and I just was zoning out. What's the purpose of the package?
The package divvies up your code into subfolders.
Okay.
It's just a way of specifying that this thing is in this particular subfolder. And that way, even if you have duplicate file names, like over here I have a header.java, and another place in my project I also need a header.java, Just like on your file system, you can't have two files of the same name in the same directory, but you can move one to a separate directory. That's what the package statement does, is it creates a directory for it.
Says incorrect package when I do this.
Yep, so if it says incorrect package, what you do is you let NetBeans fix it by coming over here, clicking, and doing move class to correct folder. That makes the error go away. Now I've created another dummy directory that I'm going to remove. All right. Why is it called an escape sequence? Does it give us the answer to that if I scroll down here? I don't think he does. Nope. All right. Maybe he does on the second page. No. All right. Primitive variables versus reference variables. Some languages do not distinguish between the two. If you've used Python, then absolutely everything is a reference variable. There are no primitive variables. If you've used C#, there are no. Everything is a class, not a primitive type. But C++ and this language support the idea of primitive data types, which are the ones which are just stored as numbers inside memory. Ints and longs and floats and doubles and chars, they're all just numbers. They don't have functions attached to them. They're just numbers. They're just little pieces of data. So those are called primitive data types. There's one more that they don't mention, which is Boolean. Right, a Boolean is just a 0 or a 1 written out to memory somewhere. Reference variables are a class. When we do that scanner is equal to new scanner business, we are creating a reference variable, which is a reference to an object of that type. So if I come into my code and I do scanner sc or in is equal to new scanner parentheses system.in, and then I do int x is equal to 3. It wants me to add the import to scanner, so I can come up here and do import java.util.whatever, or I can just let NetBeans fix it. Alright. So, this thing is a fundamentally different kind of data than this. This is just 4 bytes of data that holds a number. This is an incredibly complex beast that holds a memory address where a scanner object was created, and the scanner object has links, references, pointers to all sorts of functions built in it. So if I type in in dot, NetBeans is kind enough to list all of the members of that object, right? And there's a billion of them. To try to make, reading input from the keyboard, very easy. It's got all sorts of cool stuff in it. Next float, next double, next long, next short, and then some other ones. And it's got a wait, and I've never used the wait. And it's got has next to check to see if the next thing coming up is an int or not. So anyways,
So would that be stored in a bool then, the has next?
it returns a bool.
Well, I mean,
Correct. Right. So if we look it up, has next. That's interesting. I've never used that variant of it, but I've used has next, int to make sure that I'm reading an int or something like that, and it does return true or false, and it would be worth playing with that. But anyways, so in.next, you don't have to type this. I'm probably going to delete it. But anyways, when I typed in dot, it listed all the members, and now I'm calling a function, or as we should call it in this language, a method that is attached to that variable. So this variable is a very complex thing. Now you can write your own classes, and the classes can be super simple. Maybe they contain one piece of data. You can write a class that doesn't even contain any data, right? But then inside your class, you can also list the functions. Whoever developed this class, the scanner class, added all those functions. Of course, it grew over time, from version 1 of Java to whatever we're using now. This is a primitive data type. It has no functions attached to it. If I type x dot, There's no functions listed. There's no methods listed. It's just pure data. It's primitive data. It's just a pure number. Java doesn't even have a string type built in because a string is not a pure number. It's a sequence of numbers of indeterminate length, right? So you have to know more about that than just that, not a primitive data type. Strings are not. The way that people usually distinguish whether something is a reference type, which is another name for a pointer reference to a class, or if it's a primitive, is that if the data type begins with a lowercase number, it's a primitive. If the data type begins with an uppercase letter, I said number. Lowercase letter represents primitive data type. Not variable names, not that part, just this part, int. That's a primitive data type because it's lowercase. Scanner, that's not a primitive data type because it's capitalized, which means this is a class. Now for your code to match that paradigm, you have to create all your classes with uppercase letters in order to indicate that. And do you have to do that? Will it generate a syntax error if you don't? No, but all the Java programmers in the world will tap their foot and fold their arms and stare at you. So you're supposed to make your class names have uppercase letters. And lo and behold, the one class that we're working on does follow that paradigm. I hate that word, but yeah. Convention, that's a better word. Okay, so the primitive data types are just, chunks of bytes. There are alternate versions of these that do have methods attached to them. Like, what if you need to turn some data from a string into a double? Well, there's a method to do that. Right there. Apple commercials for iPhones. There's an app for that. If we have this integer and we have a string and we really wish that we could convert that string to a number, I'm going to make a string and I'm going to call it S, very boring, is equal to 1, 2, quote, 1, 2, 3, end quote. Now, this is not a mathematical value. It's just a sequence of Unicode characters. But what if we want to convert it to an int so that we can multiply it by itself or, divide by 5 or something? We have to convert it. Here's how you did it in Python. It's not going to work. You did this somewhere. Don't type this. No longer works for you. What if you remember our conversation about casting and you think you could do that? Nope, that does not work either. The only way we can do it is if we can parse it. Parsing it, to parse it, we need to use what's known as the wrapper class. And not wrapper like MC Hammer and Vanilla Ice. It's integer dot parse int parentheses s, end quote. That takes this string and, assuming all goes well, turns it into an integer so that we could do some math with it, right? X equals x, x plus equals 10, whatever, right? Now we could do some math with it. Now, why do we care about parsing? Well, some languages don't even have cool, convenient next ints and next floats and next doubles. Everything you read in is a string. Python is like that. C Sharp is like that, not C++. C Sharp is like that. So whenever you get data from those languages, or in those things, you have to convert it to a numeric format before you can do math on it. Now this language makes it look like we have these nice functions like nextint and stuff, so we don't need to know how to parse. Well, that's not true. There are versions of the scanner methods that return simple strings. And more importantly, if you open a file and read it, you may be reading it in as strings. If it's a text file, you may be reading it as strings. Or if you're getting data that somebody has filled in on the web from a form, they've typed in their name and their age and their mailing address, all of that is string data. And then later for you to do math on something that they've entered, like you want to validate their zip code or something like that, I don't know what, then your program has to be able to convert that string to a number. I might get to the point where I want you to use this a lot by calling .next rather than nextInt. Calling .next without specifying the type returns a string. So let's do that. And then you'll say, but why did you want me to do that? And I'll just say it's practice for when you do need to do it. System.out.println. Give me a double. Now we need to read our input in. I could use next double, but I'm not going to. I'm going to read in a string. So S is equal to IN, because that's what I call my scanner, dot next. Notice that there's, along with just dot next, there's next line. The difference is that next only reads up to the first space if you have more than one piece of data on the same line. Whereas next line would read in the entire thing. Like if you type in a first name and a last name, if you just use dot next, it'll only get the first name. But if you use next line, it'll get both pieces of data. Anyways, let's do that. And then let's convert it to a double. So double D is equal to, now I can't use integer.parseInt to read a double, so I'm going to use double.parse double, parentheses S. So we read in a string the next available string, and then we parsed it and we turned it into a double. Now, unfortunately, and this was also true of Python, the code's going to blow up if we type in some bad data. It will generate an exception. So if I run it, and what is bad data? It's data that is not convertible to a double, right? Like if it's got 2 decimal points or it's got a word in it. So down here, I was hoping to actually see it print a message. Oh, why is my code just sitting there with a little cursor? Does anybody see what I've done wrong? I'll give you a hint. It's the second uncommented line of code on the screen.
You
And
put it,
next, it's waiting for you to add something in.
Yeah, it's waiting for me to type in something there, but I forgot to put a print statement above it. All right, 4. And now say, give me a double now. Now, if I type in a valid number, it'll get converted into a double. But if I type in something invalid, like 10.3, it blows up.
Yeah.
So, what I can do to fix that is add something known as exception handling. There are other ways you can try to get around it. You can try to inspect your data to make sure that it's in the correct format.
That problem good demonstration because it was more, I didn't illustrate the exception we were trying to bring up.
Yep. Well, here it is. It's telling me that it's a number format exception, multiple points.
Well, if you delete the 2 of them and try it again.
Oh, sure. If I format it correctly, it'll work. So I'm going to run it,
Delete.
and I'm going to give it some good data. It's still waiting for me to do that int. But now, give me a double now, 2.0. It works correctly without blowing up. It is a format that is convertible, that can be converted to a double.
But if we typed in something that was a letter, that's typing a word.
Yep. If I type in a word there instead, it's going to blow up as well.
That's what I did.
Like that.
I typed the word double and
Right.
it said, give me double.
Right.
Is there a simple way to get around that? Kind of like .fail without C++? Or...
The way you get around it is ugly. Here's what you got to do. And this is like several chapters later. Try. I'm going to modify my code though. I'm going to remove this double D line. I'm going to cut it. And I'm going to paste it. And then I'm going to put a catch down here. Catch exception EX.
In fact, you might want to go up to 123 and change it to something like, change it to a word or something.
You're right, or I need to delete that, one or the other, you're right. So, catch exception EX, that's a capital E. I may have to add a, no, okay. And then inside here, I'm going to print out a message. System.out.println, that wasn't a double. All right, like that.
A real double, dummy.
Yeah. So, this catches the exception.
But another exception that you're trying to point out, go back up to where it says string S is 1, 2, 3 and type in a word, for example.
Right, and that one would blow up as well, and if I wanted to fix it, I would put it inside its own try-catch block.
But it's a different exception. Right.
Slightly different. The catch exception EX here catches all exceptions, any of them. But it's offering to fix it to the specific exception that this code can generate, which is much kinder, much less sloppy. So if after you type catch exception and you get the little warning, click on the warning and do replace, and it'll fill in the correct exception, because there's hundreds, there's thousands of different exceptions that these methods can generate.
Well, first you may want to print out
I think what I'm going to do is just delete this line of code.
a number format exception, like when you change 1, 2, 3 to a word.
Well, I'm not going to bother on that one. So here we go. That's how you can capture your exceptions. At this point in time, I'm not asking you to do that. Why? Well, for one thing, it's not the next chapter of the book, and the other is because just printing an error message is kind of dumb. What we ought to do is loop until they give us a good piece of data, right? And there are other ways of handling this. So here's what I'm going to do now is I'm going to try to handle this in a different way. What am I going to do? I'm going to comment this stuff out. In fact, I'm going to even comment that line. Source, toggle comment. And what we're going to do is we're going to ask input whether a double is waiting for us. So while in dot has next double, parentheses in parentheses, equals false, and yeah, there's other ways I could word that, then we're just going to read in whatever is there and ignore it, in dot next. And then I'm going to print out an error message, system.out.println. No, it needs to be a number. After that, I can read my value in. S is equal to in.next, like that, and then I can convert it. Double D is equal to double dot parse double parentheses in parentheses semicolon. What have I done wrong? Oh, I forgot to pass a string in. Inside the parentheses, we better put our string S there. Okay, so this is a way to handle that without using exception handling. And if I did it this way, I could have gone ahead and used, next double right there. So I think I'm going to make that as my final change. I'm going to delete that line, and instead of doing double dot parse double whatever, I'm going to do in dot next double, parentheses in parentheses. And now it won't crash. I cannot give it data which will crash, and it'll keep giving me error messages until I give good data. So give me a double now. If I type in garbage, it scolds me. Finally, I'll give it a real number. And whatever it was going to do with that 3, it can do so. I sure wouldn't mind if you made your inputs work like that. Not making it a requirement yet for it to be bulletproof, but it's nice, right? It's nice to make something that won't crash just because the user slipped their finger and they typed in 6.2, or if they accidentally inserted a letter in there. And that's an easier, I think, way of doing it than doing try-catches. Because if you use try-catch, then you have to add your own looping mechanism to let them type it in again. And so it becomes like 5 or 6 or 7 lines of code. Whereas this just wipes it out like that. Keeps issuing dot next until the next thing waiting in the buffer actually is a double. You could do the same thing with int, has next int, if you were trying to read an integer from them rather than a double.
Is there an advantage to using a catch? Like, at all?
You got to learn this try-catch syntax for a whole bunch of other stuff.
Okay.
So, as far as this is concerned, not necessarily. But exceptions can be generated by all sorts of reasons. You try to contact a server, but the internet's down, it'll generate an exception. Or you try to open a file, but the drive path, is missing, or it's a bad file name, or the file is locked by somebody else, or, all that stuff can generate exceptions. And as a matter of fact, Java makes you add exception handling for them before the code will even run. Something like has next double, it doesn't make you add exception handling to it because that would be really annoying. But if it's some kind of input-output like that, reading from a file or asking the internet for something, that is so likely to cause problems that the compiler won't even compile it without the exception handling. So we will be hitting that.
Does that next imply that there's more than one? Like a stack of?
Yeah,
Stuff
well,
you
if you
throw
just
in?
call next, it sits there and waits for you to type something in. Calling has next does the same thing. It sits there and waits for you to type something in. And when you hit enter, then the code is done. And it can go and check. Is that piece of data that's waiting in the stack's a good way to think of it, but it's actually a queue because it's not first in, last out. But anyways, data is waiting in the queue to be read. And the piece of data it checks, is it a double or not? And if it's not a double, we want to get rid of it. We want to wipe that piece of data out and wait for the next one. Is that good enough? Kind of like if you were opening a file and you were reading it line by line, but you wanted to reject the ones that were not of the correct format.
Yeah, that's what I was picturing.
Right, exactly.
There's a next, and then you're gonna get the one after that, and the one after that.
Exactly,
kind of
that's
way.
exactly what we're doing, except instead of reading from a file, we're reading from the keyboard. But you can use scanners to read from a file, and so it's the same, and you would use the same exact syntax if you wanted to ignore all the non-numeric data from your file. Well, that was a long way to go, but we have our primitive data types like ints. We have our complex data types, also known as reference data types. And then along with the primitive data types, there are wrapper classes which do the same thing but have the extra powers. Like integer x2 is equal to 3. But this one's got extra powers. x2 dot, turn it to a double. Turn it to a string. Stuff like that, right? So I could do string is equal to x2 dot to string. So it has functions attached to it because it's a complex data type. It's a utility class that makes that expands upon what an integer can do. It stores the same data as an int, but it has all these built-in functions to help you use ints, to convert them to strings or to parse from a string. Did I hear a question almost
You
formed?
had x2 dot something, and
I deleted it. I can undelete it if you like seeing it. There you go. But this statement was dumb because I didn't have a string in front of it. String s2 is equal to x2 dot to string. I'm getting error messages there. That's why I
You
deleted
don't
it.
have a semicolon.
That would do it. Okay, there we go. So if I was going to add comments, int is a primitive data type. Integer is a class that wraps the int type into an object with methods, functions. Does that mean that you need to make everything capital uppercase integer rather than an int? Nah, if you're just doing math and you're not going to be parsing it or doing stuff like that, then go ahead and use the primitive data type. It's faster. But this is a reference. Let's go back to the scanner. That example is almost a little bit confusing. This is the name of a class, and so when we want to create a reference object, most of the time, you use a new keyword. And the new keyword, followed by the name of the class, creates the class creates an object of that type and returns a reference, which is an address of that type, and stores it in that variable. And the way that Java knows what that address means is because it's a declared of type scanner. It's an object of that type. And we'll be doing a lot more classes in a minute. Just want to, future chapters. Just trying to hammer in on the idea that we have primitive data types and then we have reference types. And reference types are addresses to objects. So for example, strings. Strings have a method. They're a complex data type. They're a reference type. They begin with an uppercase S. So, if I come down here, I'm just going to scroll to the very bottom of my code and do string, well, not the very bottom, right? And while I'm here, I'm going to put end main there and end class there, just to kind of keep track of where I am. So I'm going to do string name is equal to Bob. Since this is a class, it's got all sorts of extra powers. It's got functions, methods attached to it, like if I want the length of it. Int len is equal to name dot length, parentheses in parentheses. It's actually a function, so I have to put the parentheses there. Let's get the first char of the name out. Char first is equal to, and I'll show you what I wish we could do, but then jettison it. Other languages you could do this. That would take the first character out of that string and store it into first. You've seen that syntax probably in other languages, C++, C#, Python. No, we got to do this. Name dot char at parentheses 0. That's the first letter. This is a method that says dig into your string and return the first character in it. Well, if it's the first, why is it 0? Because it's 0-based indexing. That's element 0, that's element 1, that's element 2, and so on. Here I say strings use 0-based indexing, but everything in this language does. If you have arrays, if you have lists, strings, any kind of grouping that requires numbers, they always start at 0 rather than 1. That's why we have quiz 0 and homework assignment 0 and stuff like that. So string methods, s.length, or whatever the name of your string is. Dot length is a method. A method is a function that's returned to attached to an object. Look, it would determine that that was 2. Char at specifies the character at that position. So since they've created this variable here, animal is equal to cow, then if we do char at subscript 2, then, well, that's subscript 0, that's subscript 1, that's subscript 2. I shouldn't be calling them subscripts because we're not putting them inside braces unlike those other languages. That's the index value. An incredibly important one is equals, dot equals. That's how you compare two strings. If I want to check to see what the value of that name is, here's what I cannot do. If name equals Bob. That might compile. It might work okay, but there will be times when it doesn't. The vast majority of the time, if you use equal to compare two strings, it will give you the wrong result. Let's see if right off the bat, it's probably going to work, just due to some compiler optimization. Yep, Bob. Else, I'm going to print out a message that says no Bob. System.out.println, no Bob. This looks like good syntax. You've written that same syntax in other languages. And it's not that Java is stupid, it's just they made some design decisions. And it says, yep, Bob, so I feel comfy. Hey, awesome, it's gonna work. What if I did it like this? String name is equal to Bob, and then lay plus an empty string, plus an O, end quote, plus a B. I don't think it's going to optimize that. I don't think it's going to know that, well, I should make this lowercase to match. If I print this out, it would print out Bob. But I have to be more clever to get it to break.
Something's correct.
What if I ask them for a name, and then I let them type in a name? That'll be the best thing to do. So, name is, well, let's print out what we want. System.out.println. What is your first name? Question mark. And then I do name is equal to scanner.next. Let them read. We're going to read it in. Now, even if I type in Bob, it's not going to work. It's not going to work at all. Because my scanner's named IN. IN.next. All right, so run it, give me a double, yeah, whatever. What is your name? Bob. And it says no Bob. Looks like it should have said Bob. But what it's actually doing is all equal is doing is comparing memory addresses and not contents.
There's something odd that it says reach in the file while parsing.
That means that you don't have enough closing braces. So go in and add another close brace.
I don't see what it is.
Well, scroll down, you'll see. See, that's your last one, you're gonna need one more. And you may even need another. That would be good to go. Okay, so what it's doing is it's comparing the address of this variable with the address of this string. They no longer have the same address. The compiler was optimizing it so everywhere they used the word Bob, that string had the same address so that that word wouldn't appear multiple times in the source code. And so it just happened to work. But now that we're creating our own object with some stuff that we are reading in from the keyboard, it's stored at a completely different address. And so this won't work. You never want to use equal to compare the contents of two strings. So instead we're going to use dot equals. I'm going to comment this out. And I'm going to replace it with the good code. If name dot equals parentheses in parentheses, and inside the parentheses I'm going to do quote Bob, like that. Now to work. If I run it and I type in Bob, it's going to say yep, Bob. That is how you want to compare strings. Even if the string is just a single letter, right? If you say please enter your menu choice A, B, C, or D. Don't use equal to compare it to quote A. Instead use dot equals. On the other hand, this gives us a nice little bit of business. Not only do you have equals, but you can use dot equals ignore case. And that's kind of nice because otherwise, if you were doing a comparison, you might have to check to see if they typed it in all lowercase or all uppercase or, you know, with a lowercase b but an uppercase O or whatever. That just lets it accept all of it. It converts those strings to uppercase before it does the comparison. And so even though I didn't match the case that I was comparing against precisely, dot equals ignore case did match it. Alrighty. I'm going to zip off and check out our oncoming homework assignments to see if we know enough to do them. I think we do. Did I discuss this one and then never assign it? Have we looked at one that does something with pyramids and things like that?
No.
No.
All right, let's take a look at it. Okay. This is more procedural programming. Write a program that will prompt the user for the height, width, and depth of a 3D box and calculate the volume in the surface area. Probably have already even done that in class. Next, the program should prompt the user for the radius of a sphere. And then print out the volume, the surface area, and the cross-section. We did that, didn't we? Am I getting this confused with another class? Have we done this either as an in-class thing or? Well, we're going to do it again.
Something with radius.
Yeah, well, we'll do it again. Now that it's here. And then lastly, the program should prompt the user for the height of a square pyramid. The programmer assumes that the width of the base of the pyramid is equal to the height. Well, I'm not sure if that's true of the Egyptian pyramids, that the height is equal to the width of it. Anyways, so look up the formula for a pyramid, or you can ask me, an email or text, and I'll give you it if you can't find it. Pretty easy to find. You just go to Google and type volume of pyramid, and it'll give you a great equation for it. So, since it's going to do these three conversions, part A, part B, and part C, it'd be kind of neat if you made it menu-based. And it'd be kind of neat if you made it loop. But I didn't ask for that, so you don't have to. You want to save time and just write it all, straight from beginning to end. Feel free. All right, I think that one is self-explanatory enough, but I'll ask. Does that make sense, guys? Alrighty. The next one is going to be a little bit more challenging, but if you get stuck, ask me for help. And you guys who's taking chemistry and physics classes will not have as much difficulty thinking this through probably as perhaps some others. But on the other hand, maybe it'll be easy peasy for you. Let me read you the problem instead of talking about it. Write a menu-based looping program and that asks you input from the user to perform scientific calculations. The program should work like this. Calculate temperature or calculate methane or quit. What is your choice? So they choose calculate temperature. How many grams of methane to burn? I'm going to burn 1 gram of methane. How many grams of water to heat? I have 100 grams of water. The water will be heated by 131.93 degrees. Now this is ignoring a little fact, but I'll skip that. All right, and then calculate temperature, calculate methane, or quit. What is your choice? How many grams of water do you want to heat? 2,000, like a 2-liter bottle. Heat the water to how many degrees? Or by how many degrees? 100. And that would take burning 15.16 grams of methane. And then calculate your temperature, or calculate methane, or quit. They choose quit. Okay, goodbye. So in other words, write code that asks the user how many grams of methane they have, how many grams of water they wish to heat, and then use the formulas shown on the next page to calculate how many degrees that the temperature would raise. Then, write code that asks the user how many grams of water they have, how much they want to heat it, and based on that information, calculate how many grams of methane would need to be burned to raise the temperature specified. And the way all this works, is that if you use the right units, you can calculate how many so-called joules of heat are generated by burning a substance, and you can also calculate how many joules of heat are required to raise water from one temperature to another by use of a constant known as the, in my brain dish, specific temperature. So we can have formulas for all of the above, and I say, it's okay if you don't precisely understand the formulas or terms. You should still be able to use them by providing the variable specified. But if you get stuck, ask me for help. So here's our formulas. To calculate the change in temperature based on the joules and the grams of water, that's the formula. To calculate the heat required, the joules of heat required to change a certain number of grams by a certain number of degrees, it's this equation. Those are the ones that involve raising the temperature of water. Either how hot it got based on the joules, or how many joules it took to raise it by a certain temperature. And then the next two formulas are for burning methane. This amount of joules calculated by multiplying grams of methane by a certain value. And different products generate, you know, different amounts of energy. Magnesium probably generates a heck of a lot more, you know, heat than a similar weight of methane. Calculate the grams of methane required to generate a specific number of joules. Grams of methane is equal to joules divided by that. So, those are your 4 formulas to play with in order to do these things. And in order to accomplish task 1, you'll need 2 of those formulas. You'll have to figure out the order in which to chain them. To perform task 2, you'll need 2 more of those formulas, the other 2, and you have to chain them in the right order. And if you get stuck, ask me.
Are they the same formulas?
Pardon me?
Are they the same formulas? Just
There are the formulas listed here. You'll just have to call them in order. So, what I wanted to do lastly, we barely have time for it, is to write a program that does something similar to this. But not exactly, but at least get us going. So what I'm going to do is, I'm going to tell you that there is a law called the ideal gas law that follows these variables, and if you've taken my fundamentals class, then you've already seen this equation, which relates pressure, volume, and temperature of gas. So, if we want to calculate the pressure of gas, we could say that it was nRT divided by V. And if we want to calculate something else, N requires a specific format for this to work. And so I'm going to say that N is equal to grams divided by 32. Now 32 is a magic number for oxygen. Different gases would have different numbers there. So we're just accepting that on fact. Just accept it on faith. So, if I'm going to list out what the variables are, N is equal to the number of moles. Moles is like dozens. It's a mathematical ratio of what? It doesn't matter. It indicates the number of molecules. And then R is a mathematical constant. Never changes. 0.821, that's rounded off. And then T is temperature, measured in Kelvin. Okay, so if I give you these equations, that T is equal to temperature in C plus 273.15 Celsius to K, and I give you this equation that N is equal to grams divided by 32, and that pressure is equal to N times R times T. And lastly, I tell you that R is equal to 0.821. I should be able to write a program.
you mean 0.0821.
Yeah, I goofed that one up. Write a program that asks the user for the grams of oxygen and the temperature, and calculates the volume that would occupy. Like if you have a balloon and it occupies 1 liter, but then you stick it in the freezer where the temperature is, much less, it'll shrink.
What about the pressure?
Our pressure, we're going to assume is 1. Very good point. 1 atmosphere, sea level. So I'm going to add that to my list of variables. Thank you for reminding me. P is equal to 1, which stands for 1 atmosphere, sea level. All right, so you don't need to understand all the physics to understand this. But if I tell you to read in 2 of these values and then use these formulas to calculate pressure, you ought to be able to do that. And so that's what we're going to do. So, given our givens, our inputs, will be grams of O2 and temperature in C. We will then need to use some of these formulas to get what we need. We need N, T, R, and P. Well, some of these are constants. R and P are constants, so we don't need those. But we need N and we need T. So after we've done our input, our pseudocode will look something like this. Input grams O2. Input temperature in C. What do we need in order to perform this calculation? We need some variables that we don't have. We don't have a lowercase n and we don't have an uppercase t. So how do we calculate n? N is equal to what?
Grams divided by 32.
Yep. Grams divided by 32. And how do we calculate t?
T is temp C.
Yep, that equation. With those, and assuming that we had already defined R and P as constants, we could just do so right here. R is equal to 0.028, 821, and that P is equal to 1. Now we could do our equation. That's not right. I was solving for volume. Not solving for pressure. Excuse me. I need to revise my equations. That's V, and we would divide by P there. And so this is V divided by P. Okay. So we could easily pull this off in 10 minutes. We could write a program that asks for these two things, does these equations, and gives us a result. Let's just tack it onto our existing code. And if you don't feel like typing it in as I do, that's okay. I'll upload it as notes, but I bet we can get it done. But I'm going to stick it up at the top, right after I've declared my scanner. Because I'm going to need my scanner right. But I'm tired of asking what my first name is and give me a double and all that. So I'm sticking this up at the top. So the first thing I need to do is input grams of O2, input the temperature C, do these conversions, and then do the calculation, which I forgot to put. V is equal to N times R times T divided by P. Okay. So let's tell them what we want. System.out.println. How many grams of O2 do you have? Question mark. End quote. In parentheses, semicolon. Now let's read it. And I'm going to cheat and not do any rejection of bad input. Double grams O2 is equal to in dot next double. You feel like making it fail safe? I would appreciate it. It'd be awesome. Has double, just like we did in that code down there. Now let's ask them for what the temperature is. So it's going to be another system.out.println. I'm going to save time by copying that system.out.println and pasting it. Parentheses, quote, what is the current temperature? Current temp in C, question mark. End quote, close parentheses, semicolon. Now let's make another double. Double temp C is equal to in dot next double. So handling the constants first. R is a mathematical constant, so I could conceivably use the const keyword to define it. But it's not necessary, and that's the wrong word for it in this language. In fact, I'm going to ignore all that. Int R is equal to, and I've typed this in several times, 0.0821.
And that will work.
Right.
Why did I make it an int? Yeah, make that a double. All right, and then double pressure is just equal to 1 or 1.0. Now we need to do our conversions. We need to calculate N and we need to calculate T. I could flip back to the other page, but I happen to remember them. So double N is equal to grams O2 divided by 32. If it was a different gas, like carbon dioxide, it would be a different number there. For hydrogen, it would be 2. Hydrogen is very light. Argon is a very heavy gas, and so it would be a lot larger number than 32. All right, and then double capital T, our temperature, is equal to TEMPC plus 273.15. Now we can do our formula. We can calculate. I'm going to put a comment that this is the ideal gas law, just so that the next person who comes and looks at my code understands that they can look that up. And volume, well, I haven't declared volume yet. Double V is equal to N times R times T. Now I mix some uppercase and lowercase, just keep track. I should have made them all uppercase or whatever. Divided by P. I am going to change this into an uppercase letter. I'm being totally against the rules of Java by doing these single letter variable names and by making them uppercase. But we understand what we mean. And now I could print that out. System.out.printf, parentheses in parentheses, close, semicolon. That gas occupies %.2f liters, backslash n, end quote, comma, v, parentheses, semicolon. All right, how many grams of O2 do I have? Now, just from experience as a chemistry tutor, I happen to remember that 32 grams of oxygen occupy 22.4 liters. Let's see if I get that as a result. What is at 0 degrees? 22.43. Good enough, good enough. I probably need a more specific value of R, but that's good enough. So I hope you saw the process that we went through. We used this equation and then a couple of other equations, and we chained them together in the right order in order to get all the inputs necessary to do that equation. So I hope you can figure out which order of the equations you'll need to do that burning methane. Burning methane produces joules. Those joules can be used to then heat water, and the relationship between them is all described in those 4 formulas that I gave you. And those 4 formulas that I gave you, each pair of formulas is just the same equation written another way, right? Because you know if x is equal to 1 over y, then that means that y is equal to 1 over x. You can just move the terms around. That's all that's happening in equations 2 and 4 as opposed to 1 and 3. The terms are shifting. Alrighty, let me make a Dropbox, and then if somebody needs extra time to type the code in or has a syntax error, then you'll be able to do that.
It says illegal format precision exception.
I'll come take a look at that. Alright, so this is G. We're pretty much done with chapter 3 at this point. So I say. Yeah, because we've already used the scanner class. You can read about the scanner class. Okay. All right, if you refresh your Dropbox, you'll see it. Let me bring the code back up.